Welcome to the ECE term project. Our term project is the passcode checker, and it was created by
Kelly Ang,
Eric Brar,
Brandon Fonseca,
Alex Kong,
Kobe Valley,
Eric Villagrán,
Christian West,
and Marco Arias.
For our team member roles, it consisted of me as the project manager and the attendance checker. Kobe was the video editor. No one took up the secretary, spokesperson, or organizer roles, but we all worked on the Google Slides presentation together. For the software team, Brandon and Kobe took that up, while the rest of us took up the hardware design. And for the logic table column distribution, I took up rows 1 to 10. Eric took up rows 11 to 21. Christian took up rows 22 to 32. Alex took up rows 33 to 43. Marco took up rows 44 to 54. And then Sarah took up rows 55 to 65. So far, we haven't worked on the equations, but we're going to get to that eventually.
For this project, we wanted to make a program that checks for a password when it is inputted. We also wanted to make it so that it locks you out after a certain amount of incorrect attempts.
Problem statement. We are attempting to create a login system that stores the user's information while encrypting the password. And when logging in it will lock you out if you write the passcode wrong after 3 tries for the software. While in the hardware, we are trying to figure out if we have to make all the outputs match up before opening, or can it be different?
We chose to take on this challenge because it sounded the most interesting compared to the other projects. We didn't expect that it would be as confusing as the hardware part because we thought it would be simpler. It turned out that the hardware part was our biggest issue compared to the software. Our original idea / inspiration for this was 3 tries and you'll be locked out on your 4th was a bike lock system and a phone passcode mechanism. After trial and error, we eventually let the user decide the passcode they want, and if they made an account, it will save it into the system and use for another time.
So for our software, our goals was to create a password for later use as well with the username to go along with that password to log in. And we also wanted to hide the input when putting in the password and have a lockout system for too many incorrect password attempts.
We started with the idea of a simple password checker. So our beginning code was setting up a simple comparator that only used 3 variables. First was a variable, which is the password we set. Next variable was a password the user will input. And the final variable was used to loop the system. Our first design basically separated our ideas into 2 separate components, the lockout system and just the password checker. And basically the top code basically allows the user to set the password, while the second one is a set password. But the issue with both of them was the password was stored in plain text within the code. But before we could do anything about that, we decided to combine both of these. The second design was basically that. We combined both previous iterations, and it allowed the user to set the password, but also implements the lockout system, allowing for 3 tries before the lockout. And after we discussed it, further discussed it, we decided to expand on it, but dividing it into 2 sections, which was the user registration and then user login. We had success with creating the basics of the login process. Having it ask the user to make a username and password was simple. The harder part was getting the information and saving it onto a file while also encrypting it. Another part that we also had trouble was implementing the lockout system. and we are still working on it, and it occasionally works, but also is buggy at times.
Where it starts. So at the beginning of the code, we have to import the libraries that we will be using later on. And so the code prompts the user whether or not they have already been registered on the system, and then the user will reply with a no or yes. If they have not been registered already, then they'll be sent to the user registration prompt, and then once they have an account, they could go to the login prompt, or if they already have a password, then if they already have a user, then they could just go straight to the login prompt. So for the user registration code, it is where the user gets registered. It's made up of a while loop that uses the username and makes sure that it matches. After username is set, the user is then prompted for a password. We set the parameters to have at least 8 characters, 1 capital letter, and 1 number in the password. If their password does not contain that, then they need to re-input a new password that does contain those. After password and the username is confirmed, we then use a passlib to encrypt the password before we store it on the validation file alongside its username to help improve the security of the program. For the login, the code begins by reading the file and gathering the information before asking the user for the username set. After the username matches, it asks the user for the password. If the password does not match, it gets sent back to the username input. But if the username and password are both correctly matched with what was already in the system, then they get prompted with a logged in, and that gets printed to the system. We also set a timeout system, but we have not yet implemented it.
Brainstorming for hardware design. Our first idea for the hardware was to begin with logic gates. We started doing this by sketching it out in Logic.ly. Our goal was to slowly build a system that allowed a user to click on a combination of switches, thus igniting a light that would inform the user they had correctly input the right password. However, we got feedback from Professor Tayeb, and he told us to make the truth table first. So we had to scratch our original idea and start working on the truth table. We then made a spreadsheet to record the logic and truth table that is a comparator with 3 bits, and divided the work among the hardware team, which included Alex, Sarek, Shelly, Christian, Eric, and Marco.
Right. So for the hardware design, what we have created is a comparator that gives 3 outputs for the truth table. One set of the code, P2, P1, P0, is the program itself, while the other set of code, X2, X1, X0, is the user trying to match their passcode with the programs. If the user doesn't get it right, then they'll be locked out and given another chance to try again. If the user gets it right, then they've successfully unlocked it.
For our timeline, we have a spreadsheet that you can refer to by clicking the link, but we met up on October 28th and everyone was there except for Christian. But we were basically just talking about the software parts, and the meeting was short because Kobe and Brandon took those roles. On October 29th, Marco and Sarek weren't there, but during class, we discussed again how the software looks and works while also discussing what else we need to do about the hardware. We planned to meet on Monday, November 2nd, but it didn't happen. On November 4th, we talked about how to add attempts into our coding, and we also talked about the hardware and how we should do it. Marco started by making a logic gate as well. And then on the next slide is just a continued timeline. On November 5th, Dr. Tayeb gave us feedback and steered us in the correct direction on where to begin for the hardware design, since it is twice as hard as the software design. On November 7th, we met up and discussed about what we should do for the video and how we are going to do it. And then on November 11th, we met up and talked about who is going to talk on what slides, as well as add more information to the Google Slides.
We will continue to improve on our project and continue to our development through the software and hardware departments. But for now, that is all we have. Thank you.